This is a revision video for P4c. We will discuss current, resistance and Ohm's law, and then go on to talk about mains electricity in the home and any safety features that are present. Current is the movement of charge around an electric circuit. The charge is carried by electrons. The size of the current is given by the charge passing a point in a circuit each second. The higher the current, the higher the number of electrons moving past that point every second. Resistance is the opposition to the flow of charge around the circuit. Therefore, a resistor can be used to change the current in a circuit. Longer wires give us a higher resistance because the path the electrons have got to flow around becomes greater, and therefore there is a greater opposition to their flow. A thinner wire also gives higher resistance. This is because the electrons have got to flow in a thinner path. The narrower the path that the electrons are flowing through, then the higher the resistance, or the greater the opposition to the flow of charge. If you connect a variable resistor into your circuit, then you can change the resistance, and therefore the current that's flowing in that circuit. This is a rheostat. It's a kind of variable resistor, and it's made from a very long, thin wire that's coiled around the core. The current comes in here, flows around the coil of wire, and then back out of the arm. If you slide the arm down towards this end, then you are reducing the length of the wire as you make the coil shorter. Now, we saw before that a shorter wire has got a lower resistance than a longer one because the path the electrons have got to flow down is shorter. If I move the arm this way, then I am making the coil a lot longer. This means that the electrons have got to flow through a longer piece of wire, and a longer piece of wire means more resistance. So if I want the maximum amount of resistance from this rheostat, I need to slide the arm all the way to the end point. If I want the lowest amount of resistance from this rheostat, I need to slide my arm all the way to the shortest point. Variable resistors are very useful. They can be used in dimmer switches and also in volume controls, so they can alter the amount of current in that circuit. We're now going to talk about Ohm's law. Ohm's law relates the voltage, the current and the resistance in a circuit. It's given by this equation here. V equals I times R. V is the voltage, I is the current, which is quite confusing. We use the symbol I because we can't use the symbol C because C is used for charge. So current you will always see as an I. Symbol is an I. Resistance is easy because its symbol is an R. We go back to the units. The unit of voltage is the volt. The unit of the current, to confuse you even more, is the amp. And the unit of resistance is the ohm, which is given the symbol omega there, the Greek letter. Okay? Now, if we want to rearrange this equation, we can easily put it into a triangle like this. If I want to work out the voltage, then I'll cover voltage up, and I have to do current times the resistance. If I get rid of that, and then I decide that I want to work out the current, then I'll cover the current up, and I have to do the voltage divided by the resistance. And finally, if I want to work out the resistance, then I will cover resistance up, and I'll have to do the voltage divided by the current. We can use this version of the equation in the example, which is over here. It says the voltage across the lamp is 12 volts and the current flowing through it is 6 amps. What is the resistance of the lamp? So we know already we've covered resistance up, and we've got to do voltage divided by current. So resistance is voltage divided by current, remembering that I is the symbol we use for current. So the voltage is 12 volts and the current is 6 amps. We do 12 divided by 6, that gives us 2. Don't forget the units. The units for resistance are ohms. The components that follow Ohm's law, or follow this relationship, can give us a lovely looking graph. The components for Ohm's law will always give us a straight line that passes through the origin. It's easy for us to work out the resistance of each of these resistors. We've got resistor A, resistor B, and resistor C. Now, if we want to work out their resistances, we need to do the voltage divided by the current. So for resistor A, we've got a voltage of 10 and we've got a current of 0.3. For resistor B, we've also got a voltage of 10, but we've got a current of 0.2. And for resistor C, we've also got a voltage of 10 and a current of 0.1. What I'd like you to do now is pause this video and work out the resistances of each of those resistors. So I want you to do resistor A, resistor B and resistor C. Okay, so you should have found that resistor C is our highest resistor. It has a resistance of 100 ohms. Now we could have worked that out without doing any calculations at all. All we have to see is that each of our resistors have got a voltage of 10. Then we need to look at the current. So remembering they've all got the same voltage, resistor A has got a much higher current. And we know that resistance is the opposition to the flow of current. So that tells us straight away that out of the three, this one has got the least resistance. Resistor C has got the smallest current, but it's got the same voltage, so it must have the highest resistance because it's not letting a lot of current through compared to the other two. Okay, so that's it for resistors and for Ohm's law. What I'd want you to do is pause this video and work through these two exam questions. Okay, now we're going to talk about mains electricity and the safety devices that we have. The UK mains electricity is supplied at 230 volts. In order to keep us safe from this voltage, most electrical devices are fitted with certain safety features. We're going to talk about them now. Our first safety feature is a fuse. Now a fuse consists of a wire running through the middle. This allows the current in the circuit to flow through it. However, it has got a low melting point. So if that current gets too big, it also means that the temperature will go up. If that happens, then the wire will melt. And that will cause a break in the circuit, and you should know that that will stop any current flowing. And if you stop current flowing, then you also make yourself safe from electric shock. The earth wire is another important safety device. One end of this wire is connected to the metal case of the appliance. If the live wire were to come loose and touch the case will become live. Then if you were to touch the case, you would receive a very dangerous shock. With the earth wire attached, the case cannot become live, as the current will pass down through the earth wire. This causes a surge in current, which will then melt the fuse. Then that will break your circuit, and again, it will make you safe from any electric shock. Okay, so I've talked about the earth wire, we've talked about the live wire, and we've talked about the fuse. These are all features that are within a 3-pin plug. So we've got our live wire here, which is the brown one. Okay, I always remember it, that if you get burnt, you will turn brown, and a live wire could burn you. Okay, and this is what provides the energy to the device, or the 230 volts. It's held in place by the live pin. Then we have got the earth wire. So this is one, if we've got a fault in the case, it will allow the current to pass through it and make your device safe. That's held in place by the earth pin. Then we have got the neutral wire. Its function is to complete the circuit. It's held in place by the neutral pin. Then we have got our fuse. The fuse, of course, is connected to the live wire so that if it breaks, it can cut off the circuit. Okay, so we spoke about fuses. However, fuses can come in different ratings. You can have a 3 amp, a 5 amp, a 13 amp and a 25 amp fuse. Now, what you need to do to enable you to work out which fuse you need to use is you need to know the current of your appliance. You then pick the fuse which is rated a little bit higher than the current needed. If you pick a fuse that is lower than the current needed, then the fuse will break before your device can work. If you pick a fuse which is a little bit higher, then your device will still work, but if there is a surge of current, then the fuse will break and then make it safe. Okay, so in the table, we've got a number of operating currents for different devices. What I would like you to do now is pause the video, and from the choices above, the 3 amp, the 5 amp and the 13 amp fuse, I would like you to decide which fuses you will use in each appliance. Now that bit was easier because I gave you the current in the table. Now you don't always know the current flowing through the device. However, we know that our mains voltage is 230 volts, and often if you look on your electrical device, it will give you a power rating. So therefore, you can work out the current from that. If we use our triangle, it can make it a bit easier for us. So we've got power, we've got current, and we have got voltage. So if we want current, we cover it up, and we have to do power divided by voltage. Or I equals P divided by V. So if we do that, we can then calculate our operating current here and choose a fuse which is a little bit higher than that. Okay, now I want you to pause the video, and I'd like to use the equation we just saw in order to calculate which fuse you would use for this TV. Okay, and that brings an end to this revision session on voltage, current, resistance and the mains electricity in the home.